interesting because now we've been talking about unemployment in real life a lot lately, right? Because unfortunately a lot of people are getting laid off from their jobs. It'll be interesting to see. We just had a record low unemployment, of course, before this whole coronavirus thing started, but it'll be interesting to see what happens after. Unfortunately, not going to be great. So let's look at the figure with all the squiggly lines on it. That one. Number 2. And let's talk about how the different levels of education could influence unemployment. Checking the time. Oh, good. So briefly describe how unemployment varies with educational attainment. You might have assumed this one. And again, this is a very big generalization. Of course, there are people that have less, education, but actually make more money. Unemployment decreases with more education. So you'll notice the lowest number for unemployment, this orangish line that stays mostly between the 2 and the 4% and then goes up to about 5% at the end, is a bachelor's degree or higher. But this kind of purplish, blackish line at the top, which is somewhere between 6 and 12% and then goes up to like 15% at the end, is someone that hasn't graduated high school. So unemployment decreases with more education, or unemployment is highest with less education. All right. What about B? How much more likely is a high school dropout to be unemployed than a worker with a bachelor's degree? This is a tricky one. And you can look at this in a couple different places on the chart. We are comparing, of course, the purple line at the top to the orange line at the bottom. There's a couple different ways to think about this one. If you go to the very end of the chart, this is just where I happen to look. You can look over here too. It doesn't matter. A high school dropout at the very end of the chart. I'm going to try to see if I can show you this in the lights up here. The high school dropout is right at about 12% at the end of the chart. It's right at about 12%. And the bachelor's degree person is right at about 4%. So we're comparing the high school dropout, which is at 12%, to the bachelor's degree person at 4%. So how much more likely is a high school dropout to be unemployed than a worker with a bachelor's degree? Don't say 8 because it's 8% kind of more likely, but how many times more likely is it? It would be 3, right? And you can find that just by dividing. 4%, 8%, 12%. It would be 3 times. All right, that was number 2. How are we on time again? I can't remember. 17. Okay. Number 3 is kind of a funky chart. I had never seen this number 3 chart until I started teaching this class, but I've seen it somewhere else recently too, maybe in terms of the coronavirus stuff. So in number 3, the way the chart works, and it tells you right in the little blue letters, like up here, the way the chart works is that it's the thickness of the color that represents the value, if that makes sense. It's a little funky. Let's look through A and we'll look at the chart. And again, feel free to pause the video if you're really trying to understand it, which you should be, because you will see these again in my math lab, and they're a little funky. Let's look at A. State whether the death rate for each of the, this is like real depressing. State whether the death rate for each of the 4 diseases individually decreased or increased between 1990 and 2004. First things first, make sure you're only using data from 1990 to 2004. Don't use the whole chart. We're just starting at 1990 and going through 2004. So let's go through each of the diseases. Pneumonia. Oops. How do you spell pneumonia? I don't think I nailed it, but okay, that's fine. Pneumonia is the orange color. In 1990 going through 2004, what do you think happened with the thickness of that line? Remember, it's not the fact that, I'm going to see if I can show you this again. It's not the fact that this line in 1990 was here and then it went down, right? It's how thick the line is. So I would say it decreased a little bit. Right? the fact that the line goes down has nothing to do with what pneumonia is doing. It's the thickness of the line. Let's talk about cardiovascular disease. That's the green. From 1990 to 2004, what would you say? The disease, it decreased, yeah. It was, let's see if I can show you again. It was so thick here, and then it was less thick here. Okay. What about tuberculosis? It's blue. Or it's just stayed at 0, right? It wasn't there. There's no blue line from 1990 to 2004. What about cancer? Again, this is not an uplifting section. What about cancer? The purple. What would you say? I would say it stayed about the same. I've had students say it decreased a tiny bit, or I think students have said before it decreased a tiny bit or about the same. Those are both fine answers. Okay, good. That was 3A. Let's talk about 3B. When was the death rate due to cardiovascular diseases the greatest, and what was the rate? Cardiovascular disease is green. So when was the death rate the greatest, or when was the green thickness the biggest? When would you say? I would say probably from like 1960 to 1970 maybe, or 1960 would be a fine answer, around 1950 to 1970. Any of those answers are fine. And what was the rate? Let's say we just picked one year, 1960. What was the rate? How many people died out of every 100,000 people? How many people died from cardiovascular disease in 1960? About 500, right? Remember, it's the thickness. It's not the top line, but it's the thickness. So in 1960, you'd be saying roughly 650 minus roughly 150. So about 500 people from every 100,000 died from cardiovascular disease in 1960. Right? It's the thickness. So this is B. This is number 3, letter B. It's in 1960, it would be about, what do we say? 650 minus 150. And if you're like, where are you getting those numbers from? I'm trying to show you here. So 1960, it's about 650. And then about 1960, it's about 150. So this thickness of the line, right, just like they did here, would be about 500 out of every 100,000, right? This whole chart is talking about deaths per 100,000. Again, not uplifting. All right. What about C? What was the death rate due to cancer in 2000? This one's nicer because it's just at the bottom, so we only have to look here. You could say about 200 per 100,000. So C, I would say about 200 per 100,000. And what about D? Based on the trends in the graph, speculate on which of these 4 diseases will be responsible for the most deaths in 2050, based on the trends in the graph. Trends. Not the overall numbers, but look at the trends. Probably cancer, right? The numbers for cancer just keep increasing gradually. So cancer is likely to be responsible for the most deaths. Someone has made an argument for cardiovascular disease, and I would say, yeah, that's fine. That's fine too. Again, it's all about your explanation, so make sure you're just explaining what you're writing about. Good. All right, 2 more to go. I love these maps. Do you guys like these? Anyone hike, ski, contour maps, topography maps, right? Fancy topography maps. So the contour map here has points marked on it, the closer those lines are together, the steeper it is. So if you were looking at, well, hopefully you are looking at this contour map, A and B are like the peaks on a mountain. They're like the summits to this mountain. And then as the lines kind of go out, it's like this, the mountain is going down. Have you guys ever seen these before? I hope you have. So the closer the lines are together, the faster the altitude changes. So every line represents a different altitude. Okay, so when they're really close together, that means that altitude is increasing or decreasing very, very quickly. And as they're more spread apart, it means that altitude is increasing more gradually. So when the lines are very close together, like right here and right here, that means that is very steep. You would probably not want to hike up this area. You might want to kind of go up here or go around or something because it's very, very steep. So if A and B are the peaks for A, if you walk from point A to point C, do you walk uphill or downhill? You'd have to walk downhill, right? Because you're at the peak in A and then you're going downhill to get to C. All right, B. Does your elevation change more in walking from B to D or from D to F? B to D is a much bigger change. And you can tell because there are way more lines between B and D. See how many lines there are? That means this is changing constantly, and this just means it's very gradual. Each one of these lines has to represent how do I say that? Each one of the lines, every time they change, it represents the same number. So for example, this could be, 100 feet, 200 feet, 300. It's the same change between each line. So when they're close together, right, you're changing a lot over a tiny period. And when they're farther apart, you're changing over a much more gradual time, if that makes sense. Okay, C. If you walk directly from E to F, does your elevation increase, decrease, or stay the same? It stays the same, right? You don't cross any of those lines, so it stays about the same. What is your net elevation change if you walk from A to C to D and then back to A? Nothing, right? You do change all this time, but you started where you finished, so you basically didn't change at all. Interesting, huh? All right, let's talk about number 5. Oh, I love number 5. This figure uses television sets to represent the number of homes with cable in 1980 and 2008. Note that the heights of the TV represents the number of homes. Briefly explain how this graph creates a perceptual distortion, meaning it's a bad graph, that exaggerates the true nature of the number of homes with cable. Well, you see the little TV represents 18 million homes, but that huge TV, it says in 2008, represents 98 million homes. What's up? What's wrong there? See, this is what I miss having you guys in class, because we can talk about it and discuss it. It's so much more fun. But I'll just give you the answer. The little TV, right, if it represents about 20 million and the big TV represents about 100 million, technically 5 of these should fit into this, right? 5 little TVs should fit into the big TV, but you can tell just by looking at it, much more than 5 TVs would fit into it, right? So it's much bigger. And why? Well, because the width is different too. Technically, these TVs should be the same width, and it's only the height that should change. So this may have been a cable company that wants you to believe that so many more people have cable in 2008, which we know probably not, or at least not in 2018. But they change the width of the TV along with the height. You can't do both. A bar graph would have been a more appropriate graph in 1980. And then in 2008, it looked like this. And then 1, 2, 3, 4, 5, it looked like that. So something like that. 5 of these should go into here. You get what I'm trying to say. That would have been a much more appropriate graph. All right, that's it for 5D. Guys, I hope you're doing well. I hope you're doing okay. Stay healthy, stay safe, and make sure your mental health is good too. If you need anything, you have any questions, you know I'm here. Let me know, and I will talk to you soon.